Today, let's learn about Newton's third law of motion. Well, to start off, let's ask ourselves, what is Newton's third law of motion? Well, Newton's third law of motion states that for every action force, there's a reaction force equal in magnitude but opposite in direction. Let's say if object A exerted a force on object B, what would happen? Well, based on Newton's third law of motion, for every action force, there's a reaction force equal in magnitude but opposite in direction. Therefore, object B must exert a force equal to magnitude but in an opposite direction back onto object A. According to Newton's third law, forces often exist in pairs, and one object cannot exert a force on another without experiencing a force. We can refer to this law as action-reaction, where the force exerted on another object is the action force, and the force experienced as a consequence is a reaction force. Before we get into our examples, let's start off easy with Newton's third law. You probably have experienced Earth's gravitational pull. What you might not realize is that you're also pulling up on the Earth. This is an example of Newton's third law. For example, if the Earth is pulling down on the person with a gravitational force of 100 newtons, you're also pulling up on the Earth with a force of 100 newtons. Let's start by experimenting and putting Newton's third law into action. As mentioned earlier, Newton's third law states, to every action there is always an equal and opposite reaction. When looking at this image, a missile is traveling upwards. We can see that when the fuel burns in the engine, it launches the missile by creating an upward thrust, therefore pushing the missile upwards. In this image, the action force is the fuel burning, which comes out the missile in a downwards direction. On the other hand, the reaction force is the upward launch the missile experiences from the burning fuel, pushing it downwards. Coming to our next example, Newton's third law states that for every action there is an equal and opposite reaction. Hence, the energy exerted on the first domino will react with the rest of the dominoes, making the outward force of the first falling domino, causing the next one to fall at the same rate as the first one. The act of pushing against the domino is the action force. The reaction force, on the other hand, is the next domino falling and knocking over the next one until all the dominoes are tripped over and the energy is no longer there. Newton's third law also applies to driving because when you drive, the action force is pushing against the road and the reaction is the road pushing against the tires. However, when a car collides with another car that is stationary, this can create a huge consequence. The motion of the car colliding with a stationary vehicle would cause the car that is not in motion to move forward or send it into motion. The act of car A colliding with car B is the action force, and the reaction force as a consequence is damage created as a result of sending car B into motion. In conclusion, we now understand that based on Newton's third law of motion, when one object applies an action force to the second object applies a reaction force back onto the first object. Both of these forces are equal in magnitude but opposite in direction. In addition, we now know that each object has a set force acting on it, so both of the action and reaction forces do not cancel each other out, but rather they exist in pairs as action and reaction. Thank you for watching!